What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 23 in the 6th grade math questions that North Carolina released this past school year. Now this one looks pretty daunting, but it's not too bad once we dive into it. We can see that we have a segment FG and a point P, and we're trying to find point M. We know that it's located in the third quadrant. I'll go over what that is in a bit. We know that the distance between point M and point P is half the distance between point F and point G, and we know that segment MP is parallel to segment FG. Alright, that's a lot of information, and I'm going to go over what all it means in a bit, but essentially, and you don't see the answer choices here, but we're just trying to find out where point M is. So to do well in a question like this, we'll need to know how to work with the coordinate plane, and also what it means for two lines to be parallel. Parallel lines is a minor little skill here. Okay, so I'm going to look through my bullet points, and I'm actually going to skip over the first one just for right now and focus on the second and third just for the moment. It says the distance between point M and point P is half the distance between point F and point G. Alright, so I have a word sentence here that I'm going to translate into numbers. The distance between point M and point P I will translate as MP. Is going to translate to equals. Half becomes half. And now the distance between point F and point G, I'm going to go ahead and look on the graph that the problem gave me and try to find that. Alright, so I'm just going to count the number of boxes that we're going to have to cross to get from F to G. 1, 2, 3, 4, 5, 6. So I know that the distance from point M to point P is going to be half of 6, also known as 3. Okay, so now I know that point M is going to be 3 boxes away from point P, wherever that ends up being. So next thing I see is that segment MP, so whatever little part of a line that I make, wherever I put down point M, is parallel to segment FG. Now parallel, I think the memory trick I use for that is the fact that it has two L's here. These two L's go in the same direction and they're never going to touch. Just like parallel lines go in the same direction and they're never going to touch. So if FG is completely flat, in order to be parallel to FG, this segment MP, where I take point P and point M, wherever that's going to be, has to be flat as well. So I know that point M is going to go somewhere along this line. And since I know that the distance between point M and point P is 3, I can say, okay, there's two possibilities. I can go 1, 2, 3 to the right, and point M could be there. I could go 1, 2, 3 to the left, and point M could be there. So now that I've narrowed it down to just two possibilities, out of all these points on the graph with this information, I narrowed it down to just two possible places. Now I'm going to go back to my first bullet point. And it says point M is located in the third quadrant. When I see third quadrant, I'm going to remind myself that quadrant just means one of the 4 boxes that this coordinate plane is split up into. And I'm going to remind myself that this is quadrant 1, 2, 3, and 4. So essentially we start here and just go around in the opposite direction that the clock goes. And you would probably have seen clocks by now in your math classes, but if not, it goes this way. So now that I know that point M is located in the third quadrant, out of my two possible points, one of them is in quadrant 4, so it can't be there, but then the other possibility is quadrant 3. And now I'm going to go ahead and try to remember my coordinates for this point. I know that I figure out my left or right distance first, so here I would have to go left 1. So my x value of this point is -1. And then my y value, I'm going down 8, and that's right next to the -8. Marking right there. So now I know where point M is. It's at an x of -1 and a y of -8. And at this point, I'm going to zoom in a little bit so that we can get to the actual question. Stay there. What is the first coordinate of point M? Alright, now I see -1 and I see -8. -8 is the trick answer because it wants you to mix up your x and y values here. So it can't be -8. My first number in the coordinates that I found for point M is -1, so my answer is D. The first coordinate of point M is -1.